Welcome to our video solution for problem 13 from the first Superquiz. Boy, this was a long test, huh? Okay, so in this problem, we're asked to compute a directional derivative of a function at a point 1, -2, and man, this function, wow, it just keeps showing up. And except this time, we're given the direction, right? So one thing one has to be careful with here is that the direction is given by this vector 1, -1, and that is not a unit vector. Now, when you're telling somebody the direction to go, right? Say you tell somebody, hey, I want you to go in the direction of that blue arrow. It doesn't matter how long that arrow is, you're just telling them which way to start walking. However, when you're computing the directional derivative using the gradient formula, which we would like to use here, it is absolutely essential that you normalize that vector u. So we have the directional derivative formula, and it says you need to take the gradient of f at this point 1, -2, and take the dot product not with just the direction vector, but the normalized direction vector. So this gradient, that was computed already in problem 11. So we know that this is -10, 2. But we're going to actually have to normalize this vector u if we want to solve the rest of this problem. So we know that u is equal to 1, -1. And so the length of u is equal to the square root of 1 squared plus -1 squared, which is the square root of 2. And so this tells us that the unit vector in the same direction as u is going to equal 1 over the square root of 2 times the vector u, so times 1, -1. And so this will be the vector 1 over root 2 times -1 over root 2. All right, now some people might say, well, you got to rationalize those denominators. Nah, no, you don't. All right, moving on. So now we can compute this dot product. So it'll be the vector -10, 2 dot product with 1 over root 2 and -1 over root 2. And we'll just use the algebraic version of the dot product where we just get to multiply the corresponding components and then add. So we'll end up with -10 over root 2 minus 2 over root 2, or -12 over the square root of 2. And there is our directional derivative. Now, just an aside, right? Let's say you forgot that you needed to take the dot product with u. Okay, so let's say you did something a little bit wrong. You said, okay, I'm going to write down this directional derivative, and I do the gradient of f at 1, -2, and I do the dot product with just u. You forgot to put down the u hat. And you said, okay, so what do I get here? I get -10, 2, dot product with 1, -1. Okay, this is -10 times 1, that's -10. 2 times -1, that's -2, and I get -12. Okay, notice we are not getting the same answer, right? We ended up -12 doing it incorrectly, -12 over root 2 doing it correctly. What's the difference? The difference is, of course, this 1 over root 2, right? We can do it the wrong way all we like, as long as at the end we divide by the length of u. So if we do that, okay, we'll divide by the length of u, divide here by the length of u. What was the length of u, right? The length of u we computed up above was the square root of 2. Okay, so as long as at some point we remember to divide by the length of u, we will get the correct answer. We can do it right up front, which is I usually think is a good way just so you don't forget. But hey, you started the wrong way and you want to change it sort of midstream, boom, you can just divide it at some point and you'll still get the right answer.